Hey everyone, welcome back. So we're going through shuffle strings for this casual series. For this question, we are given a string s and an integer array indices of the same length. The string s will be shuffled such that the character at the ith position move to indices in the shuffled string. And in this case, we have to return the shuffled string. So for example, if you have this test case over here, then s is equals to code lead and indices is equals to 4, 5, 6, 7, 0, 2, 1, 3. So what this means is we need to shuffle this s such that the 0 index characters come first. So in this case, let's say shuffle. In this case, this would be the character at index 0 first, which is lead, followed by e at 1 over here, which is this e over here, e. Character at index 2, which is also an e, followed by t at index 3, c at index 4, o at index 5, d at index 6, and e at index 7. So that's pretty much what we need. So for the second example, we are given ABC. In this case, it's just ABC because these three characters corresponds with the indices that each of these characters have. So index 0 is A, index 1 is B, and index 2 is C. So for the constraints of this question, S and indices are the same length and they are equal to n. And this n, in other words, the length of S and indices would range from 1 to 100, which is very lenient. So S also contains of only lowercase English characters. And in this case, for indices, the indexes in indices would range from 0 to less than n. So if you have a list of size 100, let's say S is of length 100 characters, then indices, each element in indices would range from 0 to 99. And all values of indices are unique, which makes sense because they are indexes. So credits to a friend. I was recording a previous video and I was expecting that to contain most sensible solutions. And this good friend of ours, he suggested a way easier solution. So for this video, I'll be going through that solution. And you can refer to the second video, the other video that I recorded for shuffle string for other two implementations for this question. So here's the implementation. The idea is if you iterate through indices, you would get the index and the corresponding character for each of these indices that we see is the corresponding character. So what we can do is we can create a dummy shuffle, and this can be a list of string, and we will just set this to be an empty string followed by the length of s. So what this will give us back is shuffled is equals to a list of the same length as s and indices. And the idea of this algorithm is that all you have to do is iterate through. So let's say index is equals to range of length s. In this case, index will be equals to 0. And we will proceed to get the current index inside indices. And in this case, the current index will be equals to 4. And you will get the corresponding current string as well. And this will be s at the current index. And this will be current string will be equals to c. And the idea is all we have to do is set this shuffled at index 4 to be equals to c. So if you do shuffled at current index equals to current string, then you are just setting 0, 1, 2, 3, 4, this fifth element to be equals to c. And you get the idea. The idea is you iterate through 0 to the length of s, and you get the corresponding index and string here, so c4, and you populate this shuffled list of strings at position index 4 to be equals to c. And if you do that for every single indices and characters in s, you will get a list of string where all the characters are shuffled accordingly. So if you're curious why I use a list of strings instead of just a string of length 8 for shuffled, That's because you cannot edit strings by index. So you can't do, if shuffled was a string, you can't do shuffled square bracket 0, index 0 to be equals to another character, because strings are immutable in Python. But so that is why we use lists, because lists are mutable in this case. So to trace this out all the way, to make this algorithm clear, let's carry on with index 1. In this case, this will give us back 5. The current index will be 5. Current string will be O. So in this case, we will populate index 5 with O, and we will continue. Index 2, current index at position 2 is 6. So 6 goes to, and the character at index 2 in S is D. So we will then populate index 6 with D. Let's go to index 3. Now we get current index 7, and the corresponding character in this case is D. So at position 7, populate it with D. Next, we'll move to index 4. Current index is now equals to 0, 0, and the current string is leet, so L. So L at index 1. We'll continue. Index 5, we will get index 2. And in this case, the corresponding character is E, so E. We will populate index 2 with E. Move to index 6. Then now we get 1, current index equals to 1, and current string is equals to E. And we'll populate current index 1 with E. And finally, the final index, index 7, current index is now equals to 3, and the current string is equals to T, so T. So we will populate, current index equals to 3. Sorry for the mistake there. So we'll populate index 3 in shuffled with T. And now we get Leetcode, which is the answer. So the last step would just be to return an empty string, and you join it with shuffled. And to our viewers who are not familiar with join is a function that can call on a string to use this string as the delimiter to join all characters in shuffled. And the reason why we specify an empty delimiter is because we do not want any characters between each of the characters in shuffled. We want it to just print Leetcode. But if you wanted the Leetcode to have spaces in between, then you will use a space delimiter like this. So this will give you back Leetcode. So I hope this approach was clear. So let's continue with the implementation. The implementation is actually already there, but let's just do this. Index in range length S. We'll get the current index from indices. So in this case, this will be indices at the first position. So index will range from 0 to 7. This will give you back index 4 if you were using this test case. And the current string will be equals to S at this current index, which will give us back C. So once we're done, let's also define the shuffled list of strings. I didn't define it earlier, so let's quickly do that. And once we're done, we will just set shuffled at this current index to be equals to current string. So this would set the at index 4 of shuffled to be equals to C. So this position over here. And once we're done, we will just return the join of shuffled. So that's pretty much it. Let's run this against some of the test cases. This passes, and let's submit this. And there we go. So for this approach, it's way simpler compared to the second part of the video. I would still recommend watching that video because it's good for us to understand what other ways we can use to implement this solution and what are the time and space complexity differences between the solutions. So for this approach, the time complexity in this case, multiplication is just O1, it's a one-step operation. And in this case, because we're iterating through the length of S, if you increase the length of S to, let's say, 100, then we will do this operation 100 times. So this is ON, where N is the size of S. These steps over here are O1. Assessing a character from a list by index is O1. And setting an index in a shuffled list setting an item in a list by index is also O1 as well. So all of these three operations are O1, so that's all. And joining a string in this case is also ON, because Python under the hood would have to iterate through all elements in shuffle before it can put it inside a string. So this is ON as well. So time complexity in this case is O2N. If we remove the coefficients, it will just be ON. Let's go through the space complexity. So for the space complexity, we keep a copy of S in shuffle. So this is ON. Shuffle will take up the ON space. So what this means is if you increase the size of S to 100, shuffle will be a list of 100 characters or strings in this case. So on top of that, we don't use any, we use a constant number of variables. These two variables are shared and set to a new value in every iteration. So in this case, this is O1 here as well. Index is also used here, of course, but this is O1. And this has no memory use here. Join in this case would return back a copy of shuffle, so this is also ON. So that's pretty much. So I guess space complexity is O2N if you are really stringent and you count the memory use here as well, because the join function returns back a copy of a string. But if you remove the coefficients, the space complexity is ON as well. So that's pretty much it for this demonstration. I hope that this was useful in showing the tracing process as well as breaking down the question to solve it. So with that, that's pretty much it. I hope you enjoyed it. If you do, please give us a like and subscribe, and we will see you in the next video.